Hello Professor, here is my code for the Multiplexer Lab. So for Multiplexer 2 to 1, this is the code I have, the one that you gave us in the instructions. So I have inputs A, B in the selector and output Y. This one assigns Y equal to A in selector or not selector in B. And so we go to the test bench for this. And then we have the reg ABS and wire Y, and then we call the multiplexer 2 code, and we input the A, B, S, and Y for each of their respective slots. Begin, and then we have A equals 1, B equals 1, S equals 0, and S equals 1, which is what you also what you gave us in the instructions. So when that runs for the simulation, 1 second, sorry. So in this one for the simulation, as it's running, it looks like this. Zoom in. This is what we get. Pretty simple, not much going on here. So let me close this simulation, go ahead and look at the multiplexer 4 to 1. Once it wants to load, there we go. So we go to multiplexer 4 to 1, pretty similar to 2 to 1, except this time we're using 4 inputs and 3 selectors. Still only one output Y. So we wire in Y0, Y1 to help with the outputs. So for this one, once again we call the multiplexer 2. You input the respective letters, so A, B to B, selector to selector 1, and then Y to Y0, which is the first output. Same thing here, but with C, D, selector 2, and Y1, which is the second output. And then for this one, we take in Y0, which is this whole thing, Y1, which is this whole thing, and then selector 3, and we have the final output here. And so we look at the test bench, and we have registers A0, A1, A2, A3, and S1, S2, S3 just to represent each of these inputs. And then wire Y for the output. And then this one we call the multiplexer 4 code, which is this one. And then once again we input the respective values. So A is A0, B is A1, etc. Go all the way down the line. And then we integer I for a loop later on. Begin it, we have the A0 equals 1, A1 equals 1, and all this, which is what you gave in the instructions. Then we display all of our inputs, run the loop, implement it 4 times for each input. Then begin, it runs through it, and it finishes. And when that runs, it should one second, sorry. So once this runs, it will create a new timing diagram. I should have more inputs compared to the last one. Okay, where to go? Oh, why isn't it letting me? What's going on? There we go, sorry. So we look here, you see we have 8 inputs and outputs this time compared to the 4 that we had in the last one. So this is what it looks like. It has some hexadecimals here. That's pretty standard. So then we go to the last one, which is the multiplexer 8. Whatever that one's still done. Okay. So multiplexer 8, you can see 8 inputs, 7 selectors, still 1 output. Wire Y0, Y1 for the same reasons for here, because those are our outputs. And then we do pretty much the same thing we did for multiplexer 4, except with all the new 8 inputs and the new 7 selectors. Pretty much the same thing as this one, just bigger and more tedious. So then we go to the test bench. Once again, it's really similar to this test bench. It just has more code to it. All the reg's, which is A0 through A7, and then S1 through S6 for the inputs for the selectors, and then wire Y for the output Y. And this time we call mux4 twice, and we do pretty much the same thing that we did here for these two. These two. Those two are pretty much the same as these two. So we do that, integer I again for the loop, initial begin. We do all this, got this. We made this ourselves, but it's pretty similar to this, which is what you gave us with the code. It just implements the 4 new inputs. Display all of the inputs and all the selectors. For loop, which runs 8 times this time instead of 4, since it's multiplexer 8. Begin, run through all this, finish. And then when we look at the last test bench, the last, what's it called? I already forgot. Timing diagram, sorry. Look at the last timing diagram. And we run it. And we get, oh, I don't want to delete that. Why isn't it letting me? Okay, so like the last one, way more inputs, a lot bigger than last time. Has hexadecimals, so it looks pretty standard. But compared to the other inputs, it just looks like the other ones, but bigger. So yeah, that's it for all the timing diagrams. Then we can look at the final schematic for this, which has a lot going on in there. So we go here to the schematic. I already kind of expanded it, but if we make it smaller real quick, you'll see that it has all of the implementations from earlier, mux2, mux4s, mux2, or multiplexer 2, multiplexer 4s. I don't know why that one says, oh yeah, multiplexer 4, and then multiplexer 2, and this whole one. So yeah, when you expand them again, you'll see that there's a series of and OR gates and NOT gates, which all ends up helping create the timing diagrams that were shown before. So yeah, that's my lab.